learners, our lesson for today is about System of Nonlinear Equations. The learning objectives for today are: you are going to illustrate systems of nonlinear equations and determine solutions of systems of nonlinear equations using techniques such as substitution, elimination, and graphing methods. This is the Learning Pocket concept map, and we are going to solve system using graphical method, substitution method, and elimination method. Let us have first identifying systems of nonlinear equations. Letter A. You are given the system of 2x minus y equals 1 and x plus 3y equals 5. And the answer is, it is a linear system because both equations are linear equations. Next, given the system x squared minus y equals 2 and 5x minus y equals 5. And the answer is, it is a nonlinear system because x squared minus y equals 2 is a quadratic equation, and only the second equation is a linear equation. Next, given x squared minus x plus y squared equals 4 and 2x squared minus y equals 0. This is a nonlinear system because x squared minus x plus y squared equals 4 is a second degree equation, and it is an equation of an ellipse, and the second equation is a quadratic equation. Next, xy minus 2y equals 5 and x minus y equals 1. This is a nonlinear system because xy minus 2y equals 5 cannot be written in the form of ax plus by is equal to c, and this is the standard form of a linear equation. In fact, xy minus 2y equals 5 can be written as a rational equation equivalent to y is equal to 5 over x minus 2. And the second equation is a linear equation. Do you have questions? There is none. Let's proceed. Let us have now the methods for solving a system of linear equations. First, we have the graphical method. Second, the substitution method. Third, the elimination method. Now, there are three possible types of solutions for a system of nonlinear equations involving intersection of a parabola and a line. First, there is no solution. The line will never intersect the parabola. So in this illustration, this is the parabola and this is the line. So there is no intersection. Next, one solution. The line is tangent to the parabola and intersects the parabola at exactly one point. In the second illustration, you have the parabola and this is the intersection. So only one point of intersection of the parabola and a line. And this line is tangent to the parabola. Next, two solutions. The line crosses on the inside of the parabola and intersects the parabola at 2 points. So in this illustration, the line intersects the parabola at 2 points. This point and this point. Next, there are also three possible types of solutions for a system of nonlinear equations involving the intersection of a circle and a line. First, no solution. The line will never intersect the circle. So in this manner, this is the circle and this is the line. So there is no intersection. Next, one solution. The line is tangent to the circle and intersects the circle at exactly one point. So in this manner. So this line is tangent to the circle. So there is only one solution. And two solutions. If the line crosses on the inside of the circle and intersects the circle at 2 points. So, if this is the circle, the line intersect the circle at exactly 2 points. Let us have now the solution of systems of nonlinear equations by graphical method. Example number 1. Sketch the graphs of y is equal to x squared plus 1 and x minus y is equal to negative 1 on the same Cartesian plane, and find the solution set of the system of nonlinear equations. We consider the system as a system of nonlinear equations since the first equation is a quadratic equation and the other one is a linear equation. For step 1, we have to draw the graph of the parabola y is equal to x squared plus 1. If you would like to construct the table of values, you can have it. If you would like to choose another way of sketching the parabola, it's up to you. So here, if we will construct the table of values, we have to assign values to x. So x is negative 1, 0, and 1. So if we are going to substitute negative 1 to x, and then you square plus 1, it will give us positive 2. And then assigning 0 to x and then square plus 1, it will give us 1. And assigning 1 to x and then square plus 1, it will give us 2. Then we have to plot the points on the Cartesian plane and then connect later on. Then after that, we have to draw the graph of the line x minus y is equal to negative 1. So again, we have to construct the table of values for the linear equation. And assigning values to x, we have negative 1, 0, and 1. And when we substitute negative 1 to x, then minus y is equal to negative 1, it will give us 0. Then substituting 0 to x minus y equals negative 1, the answer is 1. Then substitute 1 to x minus y equals negative 1, the answer is 2. Then you have to plot the points on the Cartesian plane and then connect the points. Let us sketch now the graphs of the parabola as well as the line. So first, we have the points of the parabola, then connect with a curve, and then we also have the points of the line, then connect with a straight line. And the blue points are the intersection of the parabola and the line. So meaning, in this system, we have two intersections. And the graphs show 2 points of intersections whose coordinates are 0, 1, and 1 and 2. So these points of intersections are the solutions of the system. And then do not forget to label properly the graph with the name of the parabola, then the name of the line, which is x minus y is equal to negative 1, and label the points. And do not forget to indicate y for the y-axis and x for the x-axis. Just highlight the points of intersections. Next example. Sketch the graphs of x squared plus y squared equals 5 and y is equal to 3x minus 5 on the same Cartesian plane, and find the solution set of the system of nonlinear equations. So the first equation is an equation of the circle and the other equation is a linear equation. First, we have to draw the graph of the circle x squared plus y squared is equal to 5. So, we need to identify the center as well as the radius. The center is at the origin because the form given is the standard form wherein the center is at the origin. So, we have the coordinate 0, 0. And the radius is equal to the square root of 5. And the decimal value of square root of 5 is 2.24. Then plot the center and the radius on the Cartesian plane, and then we have to draw the circle later on. Then draw the graph of the line y is equal to 3x minus 5. So again, you can construct the table of values for y is equal to 3x minus 5. So assigning values to x, which are 1, 1.5, and 2. So if we are going to substitute 1 to x, so 3 times 1 minus 5 is equal to negative 2. Then substitute 1.5 to x, so that is 3 times 1.5 minus 5, it will give us negative 0.5. And substitute 2 to x, so 3 times 2 minus 5 is equal to 1. Then plot the points on the Cartesian plane and then connect the points. So this is now the graph. This is the circle, x squared plus y squared is equal to 5. The radius is equivalent to 2.24. So from the center 0, 0, then you count 2.24 units and highlight this is the radius. And then you plot the points of the linear equation y is equal to 3x minus 5. First we have 1, negative 2. Then this one is the 1.5, negative 0.5, and the other one is 2 and 1. So as you can see in the graph, there are 2 points of intersections whose coordinates are 1, negative 2, and 2, 1. So this will mean the points of intersections are the solutions of the system. So this is how we identify the solutions of the system using the graphical method. Next, let us have now the solution using the substitution method. Let us have the steps in solving systems of nonlinear equations using substitution method. First, we have to choose one equation from the system that will be used to substitute in the other equation. Step 2, using the chosen equation, solve one variable in terms of the other variable. Step 3, substitute the derived equation in step 2 into the other equation. Step 4, substitute the value of the variable derived in step 3 to one of the equations to solve for the other variable. And step 5, you have to check the answer by substituting the solutions to the given equations. Let us have an example. So using the first example in graphical method, we have these 2 points as the points of intersections of the parabola and the line. Let us try to find out if the answers are the same. So given y is equal to x squared plus 1 and x minus y is equal to negative 1, we have to label this as equation 1 and equation 2. For the solution, step 1, you may choose one equation only. So, for example, you would like to choose equation 2, and equation 2 is x minus y is equal to negative 1. Then after that, you have to solve for x in terms of y. Or if you would like to solve for y in terms of x, it can be. So here, we're solving for x in terms of y. So copying the equation 2, x minus y is equal to negative 1, we have to transpose y to the other side. So it becomes positive y minus 1. So this is now the value of x in terms of y, or the algebraic value of x, which is equivalent to y minus 1. Let us continue. In step 2, we have x is equal to y minus 1. So for step 3, we have to solve the quadratic equation y is equal to x squared plus 1 by substitution method. We have to substitute y minus 1 to the variable x. Using equation 1, y is equal to x squared plus 1, we have to change x into y minus 1. So substitute the algebraic value of equation 2 to equation 1, and then we have to expand later on. So as you can see, x is being replaced by y minus 1. And then expand the square of y minus 1 into y squared minus 2y plus 1. Then simplify. So what we have is y squared minus 2y plus 2, because 1 plus 1 is 2. And then we have to transpose y to the right side. So what is left here is 0 is equal to y squared minus 2y minus y plus 2. And we have now 0 is equal to y squared minus 3y plus 2, because negative 2y and negative y is equal to negative 3y. And we have to apply symmetric property of equality. Just change the position. We have now 0 at the right side, and the trinomial is found at the left side of the equation. And then you may factor the trinomial into y minus 2 times the quantity y minus 1 is equal to 0. And then we have to equate each factor to 0. So that is y minus 2 is equal to 0 and y minus 1 is equal to 0. And then we have to solve for y later on. So y minus 2 equals 0. Transpose negative 2, it is now positive 2. And y minus 1 is equal to 0. Transpose negative 1, we will have y equals positive 1. So y is equal to positive 2 and y is equal to 1. Then for step 4, we have to substitute y is equal to 2 and y is equal to 1 to one of the equations and solve for the other variable. Here, we're using equation 2, which is x minus y is equal to negative 1. If you would like to use equation 1, you can do it. So using equation 2, at y is equal to 2, we are going to change y into 2 is equal to negative 1. And transpose negative 2, it will become positive 2. So negative 1 plus 2 is equal to 1. So x is equal to 1. At y is equal to 1, then we are going to change y into 1. So transpose negative 1 to the other side, it will become positive 1. So negative 1 plus 1 is 0. So the values of x are 1 and 0. So as I said, you can use also the other equation. So using equation 1, at y is equal to 2, then substitute the value 2 to y, and then simplify the equation. So what we have is x squared plus 1 equals 2. Then transpose 1, it will become negative 1. And then negative 1 plus 2 equals 1. The square root of 1 is 1. So it's the same. It's here. Then at y is equal to 1, substituting 1 to y, then we will have x squared plus 1 equals 1. Then transpose positive 1, it will become negative 1. Negative 1 plus 1 is 0, and the square root of 0 is 0. So x is equal to 0, so it's the same. You have the same answer. You don't have to show all the solutions. You may choose only one equation. So the solutions are the points with coordinates 1, 2, and 0, 1, which can be verified by substituting these values into both of the original equations. In the graphical method, we have also 0, 1 and 1, 2. For step 5, we have to check if points with coordinates 1 and 2 and 0, 1 are solutions of the following set of equations. First, we have to use equation 1. At point with coordinates 1, 2, substituting 2 to y and 1 to x, we will have a true equation. Therefore, the point with coordinates 1, 2 is a solution of y is equal to x squared plus 1. Next, still using equation 1, at 0, 1, substitute 1 to y and 0 to x, we will still have a true equation. Therefore, 0, 1 is a solution of y is equal to x squared plus 1. And then using equation 2, at 1, 2, substitute 1 to x and 2 to y, we will still have a true equation. Therefore, 1 and 2 is a solution of the second equation, x minus y is equal to negative 1. And at 0, 1, substituting this to equation 2, so we have 0, substitute it to x, and 1 to y, we will still have a true equation. Therefore, 0, 1 is a solution of the equation x minus y is equal to negative 1. Then, we can really conclude that the points with coordinates 1 and 2 and 0, 1 are really the solutions of the system y is equal to x squared plus 1 and x minus y equals negative 1. Let us have example number 2. Find the solution set using the substitution method. So, using the graphical method, we have 1, negative 2, and 2, 1 as the solutions. So, let us try to check using substitution method if we can get the same answer. So, given x squared plus y squared equals 5 and y is equal to 3x minus 5, for step 1, you may choose equation 2. Y is equal to 3x minus 5. If you wish to use equation 1, you can do it. For step 2, you have to solve for y in terms of x. Or if you would like to solve for x in terms of y, you can also do it. So here, we have now y is equal to 3x minus 5. Since equation 2 is a simplified equation already, you can substitute it directly to equation 1 in step 3. So there is no need to simplify y is equal to 3x minus 5 because 3x minus 5 is already the algebraic value of y. For step 3, solve the equation of the circle x squared plus y squared equals 5 by substitution method. So using equation 1, we are going to change y into 3x minus 5. This is the algebraic value of y. And then we have to expand the square of 3x minus 5, which is 9x squared minus 30x plus 25. Then equals 5. Simplify further, x squared plus 9x squared is 10x squared minus 30x plus 25, transpose 5, so we have negative 5. And 25 minus 5 is 20. Then factor the common of 10, 30, and 20 is 10. Take it out, so 10x squared divided by 10 is x squared. 30 divided by 10 is 3. 20 divided by 10 is 2. Then divide each member of the equation by 10. So you will have x squared minus 3x plus 2 is equal to 0. Then factor the trinomial. Then we have the binomial factors x minus 2 and x minus 1. Then equate each factor to 0. So we have x minus 2 is equal to 0 and x minus 1 is equal to 0. And then we have to solve for the value of x. So, transpose negative 2, we will have x is equal to positive 2. And transpose negative 1, we will have x is equal to positive 1. So, x is equal to 2 and x is equal to 1. For step 4, we have to substitute x is equal to 2 and x is equal to 1 to one of the equations and solve for the other variable, which is the variable y. Using equation 2, which is y is equal to 3x minus 5, we have to substitute 2 to x. So, 3 times 2 minus 5 is equal to 6 minus 5, which is 1. Using x is equal to 1, y equals 3x minus 5, substitute 1 to x, so we have 3 times 1 minus 5. So we have 3 minus 5, which is equivalent to negative 2. The solutions are the points with coordinates 2, 1, and 1, negative 2, which can be verified by substituting these values to both of the original equations. So, step 5, we have to check if points 2 and 1 and 1, negative 2 are solutions of the following set of equations. Equation 1 is x squared plus y squared equals 5. And equation 2 is y is equal to 3x minus 5. So using equation 1 at 2, 1, we have to substitute 2 to x and 1 to y. So we have 2 squared plus 1 squared equals 5. 2 squared is 4, 1 squared is 1 equals 5. 5 equals 5. So we have a true equation. Therefore, the point with coordinates 2, 1 is a solution of the circle x squared plus y squared equals 5. Still using equation 1 at 1, negative 2, substitute 1 to x and negative 2 to y. So we have 1 plus 4 equals 5. So 5 is equal to 5. That is a true statement. Therefore, the point with coordinates 1, negative 2 is a solution of x squared plus y squared equals 5. Then, using equation 2, substituting the point with coordinates 2, 1, y is equal to 3x minus 5. So 3 times 2, which is the value of x, and y is 1. We have 1 is equal to 6 minus 5, which is 1. So we have a true statement. So the point with coordinates 2, 1 is a solution of y is equal to 3x minus 5. And still using equation 2 at 1, negative 2, we have negative 2 is equal to negative 2. This is also a true statement. Therefore, the point with coordinates 1, negative 2 is a solution of y is equal to 3x minus 5. And the point with coordinates 1, negative 2 and the point with coordinates 2, 1 are really the solutions of the system x squared plus y squared equals 5 and y is equal to 3x minus 5. Let us have now the solution of the system of nonlinear equations using elimination method. And the steps in solving a system of nonlinear equations by elimination method are the following. Number 1. Label the equations as equation 1 and equation 2. Step 2. Choose a variable or expression that will be eliminated first. Rewrite equations 1 and 2 to equivalent equations using multiplication property to eliminate the variable or expression. Step 3. Solve for the value of the variable using the derived values in step 2. Step 4. Substitute the values in step 3 to one of the equations and solve for the value of the other variable. And step 5, check the answer by substituting the solutions to the given equations. Let us have example. Find the solution set using the elimination method. Given y is equal to x squared plus 1 and x minus y is equal to negative 1. So this is the graph. And the solutions are 0, 1, and 1, 2. So let's try to find out using elimination method if we can have the same answer. So step 1, we have to label the equations. Y is equal to x squared plus 1, this is equation 1. X minus y equals negative 1 is equation 2. And step 2, we have to eliminate the variable y first. Then rewrite equation 2. In this system, it would be easy to eliminate the variable y first. So, we have y is equal to x squared plus 1. Then we will just simplify equation 2 into negative y, just transpose x. So, it will become y is equal to negative 1 minus x. Then copy the first equation. Then subtract it to the new equation 2. So, y equals x squared plus 1 minus y is equal to negative 1 minus x. So what we have, y minus y is 0. X squared, copy. Positive 1, negative 1, copy. negative x. Then simplify the equation further. So we have 0 is equal to x squared. Positive 1 and negative 1 is 0 minus x. So the derived equation is now 0 is equal to x squared minus x. For step 3, solve for the value of x using the derived equation in step 2. This is the derived equation. 0 is equal to x squared minus x. So we will just apply the symmetric property of equality. So we have now x squared minus x is equal to 0. Then simply take out the common factor of x squared and x. It is x. So we have x times x minus 1. This is coming from x squared divided by x is x. Negative x divided by x is negative 1. Then equate to 0. Then we have to equate each factor to 0. So the first one is x. X is equal to 0. And x minus 1 is equal to 0. Then we have to simplify further. So x now is equal to 1. So the values of x are 0 and 1. For step 4, we have to solve for the value of y using the values of x in step 2. You may choose equation 1. So using equation 1 at x is equal to 0, since the first value of x is 0, using equation 1, y is equal to x squared plus 1. Substitute 0 to x, so 0 squared is 0 plus 1 is 1. So y is equal to 1. Using equation 1 still, at x is equal to 1, this is the second value of x. So using equation 1, y is equal to x squared plus 1. Substitute 1 to x, so we have y squared plus 1 is equal to 2. Or if you wish to use equation 2, that is x minus y is equal to negative 1, substitute 0 to x, and then simplify. So what we have is y is equal to 1. Just simply divide both sides by a negative 1. Using equation 2 at x is equal to 1, x minus y is equal to negative 1. So substitute 1 to x, so 1 minus y is equal to negative 1. Then transpose 1, we have negative 1. So negative 1 and negative 1 is negative 2. Just divide both sides by a negative 1, so y is equal to 2. Therefore, the solutions are the points with coordinates 0, 1 and 1, 0, which can be verified by substituting this to the coordinates xy values into both of the original equations. So step 5, check if points with coordinates 1 and 2 and 0, 1 are the solutions of the following set of equations. Equation 1 at coordinates 1, 2. So substitute 2 to y and 1 to x. And the statement is true. 2 equals 2. Therefore, the point with coordinates 1 and 2 is a solution of y is equal to x squared plus 1. And still using equation 1 at point 0, 1. So substituting 0 to x, 1 to y, we still have a true statement. Therefore, the point with coordinates 0, 1 is a solution of y is equal to x squared plus 1. And using equation 2, if you wish to use equation 2, at point with coordinates 1, 2, x minus y is equal to negative 1. So when you substitute 1 to x and 2 to y, then equate to negative 1, it will still give you a true statement. Therefore, the point with coordinates 1, 2 is a solution of x minus y equals negative 1. And at point 0, 1, we have to substitute 0 to x, 1 to y, then we still have a true statement. Therefore, the point with coordinates 0, 1 is a solution of x minus y equals negative 1. And as you can see, using graphical method, we have the same solutions. Using the substitution method, we still have the same answer. And here, using elimination method, we still arrive at the same answer or solutions. For example number 2, find the solution set of the linear system x squared minus 3 times the square of y minus 1 equals 9. and x squared plus 2 times the square of y minus 1 equals 9. First, you have to label the equations as equation 1 and equation 2. Then we have to eliminate x squared first. It's easy for us to eliminate the expression x squared. And we have to rewrite equation 2. So, equation 1 is x squared minus 3 times the square of y minus 1 equals 9. Just copy this. And then for equation 2, we have to multiply equation 2 by a negative 1 so that this x squared will become negative x squared. And by that time, we can already eliminate x squared. So, copy the first equation. And equation 2 now becomes negative x squared. Then, this will become negative 2 times the quantity y minus 1 squared equals 9 times negative 1 is negative 9. So we have now a new equation 2. So by this time, we are ready to eliminate x squared and negative x squared. So just simply subtract the new equation from equation 1. So this becomes 0. 9 minus 9 is also 0. So what is left is negative 5, negative 3, and negative 2 is negative 5. And copy equals to 0. Then we have to divide both sides by a negative 5 and cancel negative 5. So what we have is the square of y minus 1 equals 0. 0 over 5 is 0. This is now the derived equation. Then for step 3, solve for the value of y using the derived equation in step 2. So the square of y minus 1 is equal to 0. We have to expand this. So that's y minus 1 times the quantity y minus 1. And we have to equate each factor to 0. So y minus 1 equals 0 and 1 minus 1 equals to 0. And solve for y. Then solve for y, we have to transpose negative 1 to the other side. So we have y equals 1. So we have a double root. Y is equal to 1. And y is equal to 1. Then for step 4, we have to solve for the value of x using the value of y in step 2. For step 4, we have to solve for the value of x using the value of y in step 3. You may choose equation 1. So substitute y is equal to 1 to equation 1. So equation 1 is x squared minus 3 times the square of y minus 1 equals 1. And we have now x squared minus 3. Substitute 1 to y minus 1. Then you square equals 9. And 1 minus 1 is 0. 0 squared is 0. So we have x squared minus 3 times 0 squared equals 9. So we have now x squared equals 9. Extract the square root of both sides. So what we have here is x. Square root of 9 is positive or negative 3. Then step 5, we have to check if points 3, 1 and negative 3, 1 are the solutions of the following set of equations. So let us have equation 1 first. At 3, 1. So substitute 3 to x and 1 to y. So this is 3 squared minus 3 times the quantity 1 minus 1. Then you square equals 9. So this is 1 minus 1 is 0 times 3 is 0. So 9 minus 0 is 9. Then equals to 9. So we have a true statement. Therefore, the point with coordinates 3, 1 is a solution of x squared minus 3 times the square of y minus 1 equals 9. And still using equation 1, at point with coordinates negative 3 and 1, substitute negative 3 to x and 1 to y. So we have the square of negative 3 is 9. 1 minus 1 is 0. Then you square it is 0 times 3 is 0. So 9 minus 0 is 9. Equals to 9. So again, this is a true statement. Therefore, the point with coordinates negative 3 and 1 is a solution of this equation. And Using equation 2 at 3, 1, when you substitute 3 to x and y to 1, it will still give you a true statement. Therefore, the point with coordinates 3, 1 is a solution of the second equation. And still at negative 3, 1, when you substitute, it will still give you a true statement. Therefore, the point with coordinates negative 3 and 1 is a solution of the second equation. And looking at the graphs of the ellipse and hyperbola, the intersections are the points with coordinates negative 3, 1 and the point with coordinates 3, 1. Do you have questions? If there is none, see you next time. Bye!